Okay, in this video I'm going to look at the same problem, which is problem number 10, from the perspective of the law of sines. And remember, we can use the law of sines as long as we have one angle and we have the side that is opposite to that angle, which we do. We have capital A, which angle A, capital A, which is 30 degrees, and we have small a side, which is 9. And we have one other side or one other angle. And so we do have C is equal to 12, so we could solve for uh, angle C at this point using this formula from the law of sines. We couldn't solve directly for angle B or for side little b yet because those both are unknown, and that would give us an equation with two unknowns in it we couldn't solve. But at this point we have only one unknown. So when I plug in the three values that I do know, I get sine of 30 degrees over 9 is equal to sine of capital C over 12. And by cross multiplying, well, first of all, I do know that the sine of 30 degrees is 1/2. So 1/2 divided by 9 is 1/18. So I could simplify a little bit. 1/18 is equal to sine C over 12. If I cross multiplied and solve for sine of C, I would get 12 over 18, or 2/3. Now I want to find the angle C here. However, this is an important point. When I have a sine that is between 0 and 1, there are going to be two angles that give me that value of sine. And they happen to be in two different quadrants there. One between 0 and 90 degrees. One would be an acute angle and the other would be an obtuse angle, but they both would give me a sine of 2/3 there. So this is also leading us to see that there are two different angles for C. One would be obtuse and one would be acute, and that's exactly what we saw in the previous video as well. So at this point we couldn't just take the inverse sine. Now if I'm going to use my calculator to find the inverse sine of 2/3, I do need to make sure I'm working in degrees here again. So this is a reminder to always check when you're working on this test, if you're using your calculator, am I working in degrees or am I working in radians? And make sure you go back to test that and set it. Alright, so we have the inverse sine of 2/3, and we're looking for the angle in radians there, in degrees there, I'm sorry. And so we get 41.81. Now, the unfortunate thing is that this inverse sine can only return one value, but in this case there are two, and yet it's only returning the one that is the acute angle. And this has to do with the way that the inverse sine function is defined and the restricted domain of the inverse sine function. So if you were just going along at this point and you got that value, you may think that you could use that value here. And so we record angle C as having a value of 41.81. Now if this were, and it's a triangle, we know that the angles have to add up to 180 degrees. So if we were to add that 41.81 to 30, we'd get 71.81, and we subtract that then from 180, and we would get that our final angle had to have a measure of 108.189, or we could just call it 108.19. At this point we could solve for side B, and I could use either sine A over little a or sine C over little c to complete that equation, but because sine of A is 30 degrees, because A is 30 degrees, that sine is easy to calculate. And from our past calculation we know that that left side is 1/18th. And sine B we have over here, I'll take that back, we don't know sine B yet. But if we did our cross multiplication, we get B is equal to 18 sine 108.9, 108.19, which is again in degrees. And you note that that gives 17.10, which is one of the answers. So it's very important here that you note that when you have a sine that's between 0 and 1, there are two possible angles that could return that value.